Here are the solutions for problems 31 through 40 off of the Unit 2 review. Again, starting with another graph of a quadratic function. This is going to graph a parabola. So if we try to identify the vertex, notice there's nothing in parentheses here, so that means our h is 0, k is -1. So we're going to start our vertex at 0, -1. And then we can make another table. So our vertex right here in the middle, 0, -1. So I want to go 2 x values to the left, 2 to the right. I'm going to just substitute 1 and 2 in here. So I'm going back up to x squared minus 1. So 1 squared is 1, minus 1 would give me 0. 2 squared is 4, 4 minus 1 will give me 3. So then we would have 0, 3. So we would go over 1, up 1, and then 2, 3, just like counting over 2 and up 4. And I would have the same thing on the other side. So hopefully you guys are getting quite comfortable graphing quadratics. Here we have a composition of functions for number 32. We want g of r of 2. So I'm going to start by figuring out what is r of 2. So I need to use the second function over here. So that's 2 times 2 squared plus 2. 2 squared is 4. 4 times 2 will give us 8. Should have been a 2 there. 8 plus 2 will give us 10. So now we get g of 10. So now I'm going to substitute it in here. So we get the opposite of 10, or -10, minus 2, and that will give me a -12. All right, for 33, we want to graph again another quadratic function. However, this time it's not in vertex form. So let's find the vertex. We could do h is equal to the opposite of b over 2a. Opposite of b is -8. 2a, or 2 times a, is 2 times 2. So we get -8 over 4. So h is equal to -2. K then would become 2 times -2 squared plus 8 times -2 plus 13. This gives us 4 times 2 is 8. Then we'll get a -16 in the middle here. A couple ways you could do this. Let's just go straight across. 8 minus 16 is -8 plus 13 will give us 5. So we know that our vertex is -2, 5. We can make a table of values. And to make this a little bit easier, I'm going to put this in vertex form. So that means y is going to equal 2, because that's our a, times a quantity. It'll become x plus 2 squared plus 5. So my vertex is -2, 5. We want -3, -4 going to the left, -1, 0 going to the right. So I'm going to use -1 and 0. -1 plus 2 is 1. 1 squared is 1. 1 times 2 is 2. 2 plus 5 is 7. 0 plus 2 is 2. 2 squared is 4. 4 times 2 is 8. 8 plus 5 is 13. So we'll have a 7 and 13. So I'm going to have to go off my graph a little bit. So again, my vertex is at -2, 5. I'm going to have -1, 7, -3, 7. 0, 13, so we'll say maybe that'll be like right up here, and then -4, 13 right about here, and we'll graph our parabola. All right, for this problem, we're going to find a little bit of information out about it and ultimately sketch the graph of the function at the end. So for a, we need to first figure out the degree of the polynomial. So if we look at all the exponents, because right now it's in factored form, I'm going to add these up. 1 plus 2 plus 1 will give us a degree of 4. So that means the end behavior is going in the same direction. And if we were to expand this, all of the leading coefficients in here are positive. So that means the leading coefficient of the expanded form will also be positive. So we'll say positive leading coefficient. So that means on both ends, our graph is going up. So this is how we're going to write our behavior. As x keeps going to the right forever, as x increases without bound, y is also increasing without bound. So that's describing the right end behavior. As x goes to the left forever, goes towards negative infinity, y is also still increasing without bounds. So that's how we're going to answer part A. Part B, state where the graph crosses the x-axis. This happens at an odd multiplicity. So that's our first factor and our last factor here. So this is at or when x is equal to -3 and 1. C, state where the graph just touches the x-axis but doesn't cross. That's going to happen at our even multiplicities. So this is when x is equal to -1. D is to find the y-intercept. So we're going to substitute in x equals 0 for the y-intercept. So that's f of x is going to equal 0 plus 3, 0 plus 1 squared, and then 0 minus 1. So this gives us 3. 1 squared is 1 times a -1, so that's going to be at -3. So that's our y-intercept is at 0, -3. All right, so let's make a sketch of this. All right, so we know we have a y-intercept at 0, -3. We know the graph crosses at -3. -1 is going to touch and turn, and then at 1. We know our end behavior goes up, so we know at both ends, so that's going to be over here. It's going to cross through. And however far down it goes, it doesn't matter. But right here is going to be a touch and turn, so it's going to go down, come back up. It has to go back down again because it needs to cross through the y-intercept here. And then at the other end, it goes up. Now, when you actually graph this, this part right here comes down almost as far as here. But again, we just wanted to sketch. What really matters here is the end behavior. So you would get a couple points for this being correct, a point for going through here, a point for touching and turning, a point for going through the y-intercept, and then a point for crossing through when x is equal to 1. All right, for 35, here we're given a graph of a parabola. State the vertex. So the vertex here is at -4, -2. State the equation of the axis of symmetry. So that is a vertical line going right through the vertex. So the axis of symmetry, we could abbreviate it AOS, is going to be a vertical line. So we need x equals, and it's going through -4. The x-intercepts, where it crosses the x-axis, or the zeros of the function, happen at -6, 0, and at -2, 0. And then D, the y-intercept, occurs right here at 0, 6. That's all we had to do for that problem. Okay, for 36, another composition of functions. So for A, let's rewrite it as, this is saying P of Q of 1. So first I need to figure out what Q of 1 is. I'm going to use this function, so that becomes a square root of 1 plus 3. Now notice we're not having to take a square root to solve something. The square root is already there. It's a positive square root of 4, which is 2. So this really becomes P of 2. So now I go back to P of x. P of 2 would become 2 squared plus 5, so that's 4 plus 5, which is 9. For B, I want Q of P of 1. So first I want to calculate what is P of 1. So now I go to P of x. This is 1 squared plus 5, so that's 1 plus 5 is 6. So now I really am calculating Q of 6. Now I go back to Q of x. This becomes a square root of 6 plus 3. That's the positive square root of 9, which is 3. Okay, for 37, we're matching here. So let's write out everything we can about f of x. The degree of f of x is 4. I'm going to abbreviate here. The leading coefficient is negative, so that means both of my ends are opening down. Let's see what else is here. Let's find the zeros. So if I said this equal to 0. Let's try to factor here. We can do that. So we're going to get 0 is equal to, we could factor out a negative 6x cubed. That would leave me with an x and then a minus 2. So if I set negative 6x cubed equal to 0, notice it's a multiplicity of 3. It's going to cross. It's going to be x equals 0. I also have a multiplicity of 1 here, so I have a graph that crosses through 0 and 2. The end behavior is going to be the same direction. So I'm looking at A, C, or D. Since my leading coefficient is negative, it's going to open down, so that rules out C. So I'm looking at graphs A or D. So now I go to the x-intercepts at 0 and at 2. So that's ruling out A. So it looks like D crosses through 0 and 2. So that looks good. So this would be f of x. So now I can rule out graph A, graph C, and graph D for the graph of h of x. So if we take a look at h of x, this also opens down. The degree is going to be 3. Since, or not opening down, but the leading coefficient is negative. So that means for an odd degree, leading coefficient is negative, it's going to rise to the left, fall to the right. So that could rule out B. So now I'm looking at graphs E and F. So let's find the zeros. So the zeros, I have a multiplicity of 2. So at x equals 1, it touches and turns. And then x equals 3, it's going to cross through. So that's ruling out E. If you take a look here, graph F at x equals 1, it touches and turns. It rises to the left, falls to the right, and it also crosses through x equals 3. So this is h of x. So these are like the little pieces that we need in order to match. So graph E is out. All right, for 38, we are graphing an absolute value function. The vertex, notice it doesn't shift to the right or left or up or down, so the vertex still stays at 0, 0. But technically the slope is negative 2 over 1, so this is going to open down, and I count down 2 squares and 1 over to either side every time. So here's what the graph of this looks like. Okay, for 39, we are asked to list the possible rational zeros here. So this is where we want plus or minus p over q. So we get plus or minus. For p, I'm going to the end, the constant. So I get plus or minus factors of 2, plus or minus 1, plus or minus 2. For q, I go with the factors of 5. So plus or minus 1, plus or minus 5. So the possible rational zeros are plus or minus 1 over 1, so plus or minus 1, plus or minus 2 over 1, so plus or minus 2. Then I do plus or minus 1 over 5, and then plus or minus 2 over 5. Those are my possible rational zeros. Okay, and then for 40, we want all vertical and horizontal asymptotes. We're going to graph them. So let's start with vertical asymptotes. That's where our denominator, negative 3x minus 6, would equal 0. So we solve for x. We'll add 6, divide by negative 3. So our vertical asymptote is x equals negative 2. For the horizontal asymptote, let's take a look. The degree of our numerator, we're going to say n is really equal to 0. There's no variable here. So the degree of our numerator is 0. The degree of our denominator is a 1. So in this case, n is less than m, which means we have a horizontal asymptote of y equals 0. So now we're just going to graph these two. So x equals negative 2 would be a vertical asymptote right here. Y equals 0 is right on the x-axis. So there's our horizontal asymptote in purple, vertical asymptote in green.